Now we come to the point where we'll see the graphical representation of sound wave and we'll discuss its characteristics. So, as with the example of tuning fork, you have seen the vibration of arms of tuning fork or any vibrating object produce variation in density. Now, for the graphical representation of sound wave, we will see the example of tuning fork or any other vibrating object producing sound, and we know that there will be the variation in density of the particle throughout. As in compression, they will be crowded together, and in rarefaction, they will be spread apart. Because of the density variation of the particles in the medium, we can say there is a pressure variation as well throughout in the medium. So where density is more, whereas compression there in the medium, the region will be of high pressure. And when there is a rarefaction, there will be the low pressure zone. It is clear from this picture, density variation as well as pressure variation in the medium because of the sound wave. So, to represent sound wave graphically, we will take density or pressure variation with distance here. Okay, the high pressure or the high density areas where we can see the compression are the upper part of the curve. And rarefaction, low density or low pressure area are the valley of the curve. The point where we'll have the maximum pressure is the top of the curve, is known as crest. And the point of minimum pressure is the lowest point of the valley and is known as the trough. And here you can say that sound wave is looking like a sinusoidal wave, but it is representing variation of density or pressure with distance. And this is a very convenient form to represent sound wave. Whereas sound wave is a longitudinal wave, it is not a transverse wave. The motions, particles are not moving up and down. It is not happening here. It is the representation of pressure or density variation. Now about the wavelength. Now we have seen the sound wave is represented as a sinusoidal wave. The distance between two crests or two troughs is known as wavelength, and it is represented with lambda. And as you have seen in the wave representation, this axis represents distance. So very clearly, what will be the unit of wavelength? SI unit of wavelength will be meter because it is measured in distance. Okay, so this represents the wavelength, or in other words, if I take a sinusoidal wave here, going like this, it is one cycle. This represents the one cycle of oscillation. So here is wavelength, that is distance between two consecutive compression or two consecutive rarefaction, represented with lambda. So if I am saying the wavelength of a wave is more, then what we will say? It will look like, if I take two waves, one is looking like this, it is lambda 1, and one is looking like this, its wavelength is lambda 2. So we can say lambda 1 is greater than lambda 2. So this is the distance between two consecutive crest or turf, or a distance of one full cycle. This will be representing one full oscillation, starting from the neutral position, going up to the maximum, going down to the minimum, and then coming back to its normal position will be called one oscillation. Okay, so now with this oscillation we can define frequency. Now it is frequency. Frequency is simply representing how many oscillations per unit time are happening in that wave. Okay, that is called frequency. Again, it's the number of oscillations, number of full cycle per unit time is called the frequency of a sound wave, and its unit is hertz, and its representation is nu or generally f. So this is about the frequency. Here you can see high frequency sound wave and low frequency sound wave. Now we will try to define the time period of it. Okay? Time period is nothing but the time taken for one complete oscillation in a given medium. That will be the time period of sound wave, and its unit will be seconds. And simply you can relate time period and frequency as nu is equal to 1 upon t. Low frequency means higher time period, and high frequency means lower time period. So you can say if higher is the frequency, lower is the time period, and lower is the frequency, time period will go high. So frequency and time period are related. Nu is equal to 1 upon t. Clear? So these are very important characteristics of sound wave that we have discussed about is wavelength, frequency and time period. Now there are few practical things like we call it pitch. Pitch simply gives us information about its frequency. Higher the frequency, higher is the pitch. This is a low frequency wave, so we will call it a low pitched sound. And here you see the high frequency sound, which will be called high pitched one. So simply pitch is giving us information about the frequency of the sound. The next characteristic is amplitude. So the graphical representation of sound wave gives us information about all these things clearly in a picture form. Amplitude. Amplitude in general what you call the volume. Amplitude actually represents the energy of the wave. So low amplitude means soft sound. Amplitude is actually the distance from its normal pressure to the maximum pressure or normal pressure to the minimum pressure. Distance between the crest and the normal or distance between the trough and the normal is known as amplitude. This is a low amplitude wave. This is a high amplitude wave. So low amplitude means low volume. You can say it's a soft sound. Higher the volume, higher the amplitude means louder the sound. In other way, this represents energy as well. If you speak with little energy, if you speak softly, you hear the softer sound. But if you shout, you are putting a lot of energy into it. So what is the thing that is changing in the sound quality? That is its amplitude, that is its volume. So actually what is changing? Its energy. So because for the sound waves, our y-axis represents density or pressure. So for sound waves, the unit of amplitude will be of density or pressure. Okay, now another one is defined as the quality or the timbre of sound. Like, when you hear two people speaking in the same volume with the same frequency, still you can distinguish. It is Mr. X, it is Mr. Y. How? Because of the quality of it. Okay, that enables us distinguish between two sound like male and female voice. You can distinguish. So the sound which is more pleasant to listen to is called of rich quality. Here, if we talk about a single frequency sound, if there is only one frequency, then it is called tone. But if it combines lot of frequency, quite a few frequencies are combined together, like in orchestras, then we'll call it note. So this is about quality, note, and tone. So until now, what we have discussed about sound and its propagation, we are clear that it moves with a finite speed. Okay, because the medium involved, because the particle movement is involved. So it moves with a finite speed. But the speed of the sound depends on the medium itself and few characteristics of the medium itself, like pressure, moisture, density, and etc. For this class, it is enough to know in the solid, sound wave will have the maximum speed compared to liquid, and then last one will be the gas. So the sound will travel fastest in solid, then in liquid, and then gas. In a given medium, if you change the temperature or the pressure of the medium, the speed of sound will vary. If the temperature is higher, the speed of sound will be higher. So this is about the speed. Here is a table given to you. You can see in the solids, the speed is quite high compared to liquid, and in the gaseous state, the wave travels with quite low speed. So this is about its characteristic. So we have discussed about its wavelength, frequency, time period, pitch and amplitude, quality and speed of sound wave.